All right, so the reason you click this link is to try to learn how to change a percent change, or sorry, turn a percent change into an exponential function. And so here's kind of a classic example. Let's say you have a credit card that has an annual percentage rate of 14.2%. If you have a balance of $1,400, write a function that represents your balance on your credit card if you make no payments and receive no penalty fees. I'll write this in purple here. So the issue here is that is the following. So let's say you have $1,400. The annual interest rate is 14.2%, and so if you make no payments after a year, it's going to go up 14%, and so you will owe them more. You can think of interest as sort of one way I've heard it talked about is it's kind of a rent on your money, and so they loaned you this money, and in order for to enjoy the privilege of having that money, they are going to charge you for it, and the rate they're going to charge you is 14%. And so how does it go up 14%? Let's make a couple of calculations here. Well, we need to know what 14% of 1,400 really is. In order to do that, that's going to be 0.14 times 1,400. Which is equal to 196, and that's just a thing you need to remember when you find the percentage of something. You take the decimal form of the percent and multiply it by the total, and so it's going to go up 14%, or $196. And so my new total, my new balance, is going to be 1,400 plus 196, and this is the same as adding 14%. And that will give me a total of $1,500.96 that I owe. All right, so here's the big rub with these things, and it's that if I go up 14% again, this time when I go up 14%, they are going to charge me 14% on $1,596, which is different from 1,400. So they're not going to just charge me another 196 bucks. They're going to charge me 14% of 1,596. So I need a new calculation, and this new calculation looks like this. I guess I can use, let's use red this time. I guess I've already used that. And so the calculation to add 14% is going to be down here in green. 14% of 1,596. And so 14% of 1,596 is going to be 0.14 times 1,596, and that gives me 1,500. $223.44, and so this is the same as adding $223.44. So this big crazy thing is that when you are charged a constant percent interest rate, you pay more and more every year on it. So 14% of $1,400 is $196. And that gives you an increase next year of $223.44. And so in this case, when it goes up by 14% again, you end up with $1,819.44. And so when you're looking at this, a constant percent change based on the interest rate actually creates a non-constant non-linear change. It's going up by more and more. It's not changing by the same amount every time. And so because it's non-linear, we have some other types of functions available to us, and luckily this is one that you are learning how to handle. It's an exponential function, and I want to show you how that works. And so when I look at this, I can calculate these three guys here, and I'm going to get rid of some of this information so that I can just keep my calculations here. I'm going to show you a technique that you can use to find the common multiplier. So let's say I've got these three pieces of data. I know that they happen at year 0, year 1, and year 2. So now I'm kind of dealing with a table. In order to find what I multiply 1,400 by to get 1,596, I can use the opposite. And so I'm trying to figure out what do I multiply by, because I suspect this is exponential, and we know that exponential functions have common multipliers. If I don't know what it is, I'm going to take 1596 and divide it by 1400, and that will give me the common multiplier, because division is the opposite of multiplication. So that's 1.14. And so I no longer have a question about that. It's 1.14 that I'm multiplying by. And I can test it. I'll do 1400 times 1.14. Boom, it is 1596. Now I have to test it to see if it's a constant multiplier, and it's indeed exponential. I'll multiply by 1.14 again, and I get 1819.44. Okay, so I found the constant multiplier by working backwards and dividing, so I know that I'm multiplying by 1.14 at this point. So I could write the function y equals 1400, it starts there, times 1.1 to the x, because it multiplies by 1.1 over and over again. There's my function. Now let's say that you don't want to do all of this work every single time, and you want to be able to jump by I'm sorry, I calculated at 14%. You want to jump by straight from this problem to the function, and you can do that. Here's how it works. You will notice that we were using an interest rate of 14%, and so when dealing with that interest rate of 14%, you'll also notice that I have 14 right here as a part of my function, or as part of my multiplier. I apologize, I didn't write 1.14, I wrote 1.1. Let me adjust that here. So it should be 1.14 to the x. My apologies. Okay, so that 14% ends up right there as 1.14. And so another way to think about a 14% increase is that here, if this is 100%, I'm going to add 14% and get 114%. And so what is 114% of 1400? Well, it's the same as 1.14 times 1400, because 114% is 1400. And so we are repeating this calculation over and over again, but we are adjusting what we have right here. So you take 1.14 and multiply it by whatever you had last to get what you have now. And so when you see that interest rate of 14%, you can just tack it on after 1, and it becomes 1.14. As a for instance, if I wanted to write a similar problem that had an interest rate of 19.2%, whoops, that was a weird mark, 0.2%, and a balance of $1,000, I know that it starts at 1,000 and that it's going to multiply by something, because a percent change increase is always an exponential function here. So 1,000 times 19.2, well, 19.2% increase is 100% plus 19.2% gives me 119.2%, which is the same as 1.192. And so I multiply by 1.192 over and over again. And so there's my function. All I did was take 1 and write 192 after it, because that's my percent change. You'll see more problems like that in the future on your second investigation, and you'll notice too that you'll have to use this particular technique. You may want to come back to it and review it when you do the last problem in this investigation.